again. So I'm just going to have a video here for you on what to do when you have two reactants, so two or more reactants with masses for each of those. In the preceding video, we went over what to do, how to figure out the mass of product when you only had one of the reactants in the equation, or in what's given in the problem. But here we have two reactants, and so how do we deal with that? Well, basically it's going to be exactly the same as we did on the preceding video, where we figured out the mass of product from the mass of reactant. But here we have to do that twice, once for each reactant. And the one that produces the smallest amount of product is what we refer to as the limiting reagent. And that's the amount of product that we can produce. We can't produce any more than that, because we run out of that particular reactant. So let's just kind of do an inventory on what we're given. So let's first off write down things that we look up or are given. First off, we look up the molecular weight for sodium. That's 22.99. Cl2 is 70.90. And sodium chloride, 1 mole of sodium chloride is 58.44. Now, the amount given, the mass given for sodium is 11.138, and for chlorine is 11.371, and we have to figure out the amount of product. Okay, something just happened. There it is. I didn't see the masses in there. So anyway, what do we do? Well, we have to write the equation that we used last time to solve, and we're going to do it for sodium first. So we're going to figure out the mass of sodium chloride that we would produce if we ran out of sodium first. So we'll use the mass of sodium chloride will be equal to the mass of sodium times the molecular weight of sodium chloride over the molecular weight of sodium times the ratio of the stoichiometric coefficients. In this case, each of them is 2. So we'd have 2 over 2. Now, of course, we're now ready to put numbers in. So we look up the mass of sodium is 11.138. The molecular weight for sodium chloride, 58.44, divide by 22.99 times 2 over 2. Do the math for that, and we decide that we have 28.31 grams of sodium chloride would be produced if sodium is the limiting reagent. Now we're going to do the same exact thing for chlorine, as if chlorine's the limiting reagent. So we'll just draw a little line there to differentiate the process. So the equation, again, is going to look just like the other one, except everywhere we had sodium, we're going to replace the information about Cl2. So the mass of sodium chloride will be equal to the mass of Cl2 times molecular weight of sodium chloride divided by the molecular weight of Cl2 times, now we have to look up the coefficients. The coefficient for sodium chloride is 2 as before, but the coefficient for Cl2 is 1, implied 1, so we'll put that there. Now we're ready to put numbers in, because we have all the numbers we need. So we look up the mass of Cl2 is 11.371 grams. Molecular weight of sodium chloride, as it says above, 58.44, and then divide by the molecular weight of Cl2. That's 70.90, and then include the 2 over 1. Now we do the math for that, and we end up with 18.74. Now we have to compare these two numbers here, and clearly the 18.74 is smaller than the 28. Let's put units in here before I forget. So this is the theoretical yield. This is the maximum amount of yield we can have, because if we when we consume all of the Cl2, we've only made 18.74 grams of sodium chloride and no more. So this is what we would refer to as our theoretical yield. And Cl2 is our limiting reagent. So I'm not going to go through it here, but you could use the theoretical yield along with an actual yield, which would be less, to come up with a percent yield. Again, you would use the amount of product produced based on, theoretically produced based on the limiting reagent as your theoretical yield, and then your actual yield would be, of course, what you measure in the lab. So that's fairly straightforward. Okay, well, I hope this kind of clarified a few things that might have been causing you trouble, and hope you have a great day.